Okay, so today we're going to talk about 8.1, 8.2, and 8.3. So 8.1, we're going to start talking about the square root property. So the square root property just says if some algebraic expression, u, and d is a non-zero real number, then if we have this u squared, so some algebraic expression is equal to some number, that's just equivalent to the square root of the algebraic expression, right, is equal to the square root of the d, right? So our non-zero real number. So all we're saying here is that we have u squared, right? And we have d, right? So that's our first line from before, right? And all we're doing here is just square rooting both sides, right? So we have the square and square root cancel, so we just get u. And then the square root of d, since we took the square root on both sides, we have to include the positive and the negative cases, right? So we have positive and negative square root of d, which is just some number, okay? Okay, so we're going to use that property to find out the answers for variables, right? So we usually just use x. So if we go down to our first example here, we have 4x squared is equal to 49. So the first thing I'm going to do is just to solve this is to start simplifying the side with the variable on it, right? So the very first thing that I can do here is I can divide both sides by 4, right? So if I divide both sides by 4, I get x squared is equal to 49 over 4, right? And then notice that this equation now is just like our equation up here, right? So we have some algebraic expression on the left, and we have just some number on the right. So what we can do now is take the square root of both sides. So if I do that, we get x is equal to, we have to take the plus or minus case, right? So the positive and the negative case. And then we can take the square root of 49 over 4. And notice that we have a perfect square on the top, and we also have a perfect square on the bottom, right? So what I can say is, if I have the square root of something, I can take the square root of the top, and I can also take the square root of the bottom. So we get x is equal to plus or minus the square root of 49 over the square root of 4, right? And the square root of 49 is 7, the square root of 4 is 2. So this is just equal to plus or minus 7 over 2. Right? So those are our answers. Those are our solutions to the equation. We either have x is a positive 7 over 2 or x is a negative 7 over 2. Okay, so we can do a similar case for the next one, right? So this one I want to simplify it as much as possible. So the first thing I'm going to do, I think, is I'm going to subtract by 49 on both sides. So if I do that, we end up with a very similar looking equation where we get 4x squared is equal to a negative 49, right? And I can divide by 4 again on both sides. So I get x squared is equal to a negative 49 over 4, right? And then the last thing I can do is square root both sides, just like I did before. But notice we have a negative on the right side. So I have x is equal to plus or minus the square root of negative 49 over 4. And then remember when we dealt with imaginary numbers, so we have that negative, and we can pull that out by saying, well, this is just equal to plus or minus the square root of negative 1, right, multiplied by the square root of 49 over 4, which we already know is 7 over 2, right? And then remember that the square root of negative 1 is just equal to I, right? That's our imaginary number. So we have x is equal to the plus or minus 7 over 2I. Okay, moving along, we'll do the next one. So the next one we have is 3 multiplied by the quantity of x plus 2 squared is equal to 36. So to start simplifying this, I think what I'm going to do is divide by 3 on both sides. So we get x plus 2 squared is equal to 12. 36 divided by 2 is 12. And then notice that we have something on the left squared, right? And that's equal to just some number. So this is exactly like what we had up here, right? U squared is just some algebraic expression, right? And all this is on the left is just our algebraic expression. So what I can do is square root both sides. And if I do that, the left side cancels, right? We have a square root and a square. So we just get x plus 2. And whenever we do a square root, remember that we have to take the plus or minus case. So we have plus or minus the square root of 12. Okay. And then the last thing I need to do to solve for x is just subtract 2 on both sides, right? So if I subtract 2 on both sides, we get x is equal to, I'll put the negative 2 out front first, plus or minus the square root of 12. Just to make sure we don't confuse that the negative 2 isn't under the square root, right? And those are our two answers. So we either have x is equal to a negative 2, a negative 2 plus, negative 2 plus, my pen's not working. Negative 2, there we go, plus the square root of 12, or we have x is equal to, a negative 2 again, right? Negative 2 minus the square root of 12, right? So that's our plus or minus. Okay, so we've solved this page, right? We've done our 3 equations that it asked for. We've solved to find the plus or minus answer for x, right? And that's all we're trying to do here, is we're just trying to find out what x is equal to. Well, what if we have maybe something else in there? Maybe we have a term like this, where you have bx, right? So if we have something where it's x squared plus bx, right? We call that a binomial. There's 2 terms. What we can do is we can get a perfect square by adding this b over 2 quantity squared term, right? So that's just where we get this perfect factorable term, and we get a really nice result, right? So when we add this b over 2 squared term, we can factor all this into x plus b over 2 squared, right? That's just what our factoring is. We just have these perfect squares, right? So that'll come up a lot when we're trying to solve for equations, right? Because we can just add this on both sides. We can add this term on both sides. And when we add that term on both sides, the left side is going to factor really nicely. The left side is going to factor really nicely into this, where we get x plus b over 2 quantity squared, right? And then we can just take the square root on both sides and solve for x that way, right? So it's going to give us a really nice method to be able to solve for x in these cases. Okay, so let's just try some examples. This one says, what term should be added to each of the binomials so that the perfect square is a trinomial, right? So we get a perfect square trinomial. And then it says write and factor the trinomial. So notice this b here lines up with the b in front of just the x term, right? So if I look at this first example here, notice that our b here is negative 12. So if I wanted b over 2, well, that would just be negative 12 over 2, right? And then we obviously have to square that whole thing, right? So what we get, negative 12 divided by 2, is what? Negative 6 squared, okay? And I think instead of, maybe I'll rewrite this really quick. So we get x squared minus 12x plus, right, a negative 6 squared. So we're adding that third term in there. And the reason I'm not simplifying this more is because we know exactly what this evaluates to, right? We know, or what it changes into, right? So we know that it's x plus b over 2, right? B over 2 is just negative 6 in this case. And then that whole thing is squared, right? So we're just kind of seeing what our values are and changing it into this form. And then after I do that, notice that there's a little bit of simplification that can be done, right? So we just get x minus 6 squared. Okay. Okay, so that's good for that one. What about the next one? So we have x squared plus 10x, and we want to find what this perfect square is, right? It's plus, oops, it's plus b over 2 squared. In this case, b is 10. So we have 10 over 2 squared. Notice that simplifies to 5, right? So our b over 2 is just equal to 5. So when we want to simplify this, we get x plus b over 2, just 5, right? Squared. So this is just equivalent to that, right? So we're just kind of factoring it out. And if you want to, you can always check yourself, by the way, right? We can just check by our, sorry. Yeah, we can just check that, right? If we distribute this, right, if we FOIL this back out, notice that we'll get the exact same thing back. Okay? We'll get the exact same thing back. Okay. All right, so we'll move on to the next page. So the next page, we're going to solve some quadratic formulas by completing the square, right? So we're going to use that method that we just learned, this completing the square. So I'll rewrite it again. We'll just have, it's what, b over 2 squared, right? So b over 2 quantity squared. When we have something like x squared plus bx, right? That's what we need to be able to factor it into the x plus b over 2 quantity squared. We get x plus b over 2 quantity squared, right? So we just need that on one side. Okay, so what we're going to look at is this one down here. So it says solve by completing the square. So the very first thing we have to do is make sure that our coefficient of the second degree term is not 1, right? So notice that we have a 5 here in front of our x for the first one, right? So that's satisfied. And then we want to divide both sides, sorry, the second degree, which is this one, right? So notice that it doesn't have a coefficient of 1, right? It has a coefficient of 2. So what we're going to do here is divide both sides by that number, so we have a coefficient of 1, right? So I'm going to divide everything by 2. If I do that, notice we just get x squared, right? So we get x squared. We get 5 over 2x, 5 over 2x. And then negative 3 divided by 2 is a negative 3 over 2. And that's equal to 0 still, right? 0 divided by 2 is still just 0. Okay. And then what's the next step? Well, the next step, I want to isolate the variable terms on one side, right? So the way I can do that is getting rid of this negative 3 over 2x on the left side. And I can do that by doing the inverse operation, right? So I'm going to add 3 over 2 on both sides. So we get x squared plus 5 over 2x. I'm going to leave a little bit of space here, is equal to 3 over 2, right? It's equal to 3 over 2. So after I do that, and the reason I left some space is number 3, right? So I want to complete the square by adding the square of half the coefficient of x on both sides, right? So that's just this b over 2 squared term. So notice that my b over 2, b in this case is 5 halves, right? And if I want to divide that by 2, I get 5 over 4, right? So I'm going to add to this my b over 2 term, right? And then notice that this is squared, right? So b over 2 squared. And whatever I do to the left side, right? Since I added a 5 over 4 squared to the left side, I have to do the exact same thing to the other side, right? Because we have to keep these equations balanced, right? So whatever I do on the left, I have to do on the right. And then notice I don't need to factor, or I don't need to do 5 over 4 squared, right? I don't need to do that because I know that on the left side, I'm just going to factor this into x plus b over 2, right? Which is the 5 over 4. Oops. Which is just the 5 over 4 squared, right? So that's just what it factors into. and then I can add the other side, right? So notice that I'm going to get 16 on the bottom when I square this. So I'm just going to convert this 3 over 2 into 16ths. And if I do that, notice that I get 24 over 16, right? So if I just convert that 3 over 2 into 16ths. And then on the left here, or on the right rather, we have 5 over 4 squared. So we square the top, square the bottom. We get 25 over 16. Okay, we get 25 over 16. Okay, so now that we've done that, we can square root both sides, right? So we just have this on the left side, we have just some terms squared, right? So we'll square root both sides. So we'll get x plus 5 over 4 on the left. And notice when we square root the other side, we'll add these together really quick, right? So we get the plus or minus square root of 49 over 16, right? When we add those like fractions together. And then we can keep simplifying, right? So notice that the right side, 49 over 16, those are both perfect squares. So we get x plus 5 over 4, 5 over 4, is equal to plus or minus 7 over 4, right? After we take the square root of that. And then notice that the very last thing we need to do is just subtract 5 over 4 from both sides, right? So we're just still solving for x. So x is equal to plus or minus 7 over 4 minus 5 over 4. Okay. So plus or minus 7 over 4 minus 5 over 4. Right? Okay. So let's try one more of those examples, and let's do the same thing down here. So now I won't be showing the steps as far as, on the screen 1 through 5. But we can do the same thing when we're just solving for x. So on this first one, I think what I'm going to do is add by 1 on both sides, right? Because I noticed that my coefficient's 1 in the front, so I don't need to divide by anything. But notice that if I add 1 on both sides, we get x squared plus 4x. And I'm going to leave a little bit of a space here, right? Because we're going to have to complete the square, is equal to 1. That's equal to 1. And then the question is, what is b over 2? Well, notice b here is just 4. So if we do 4 divided by 2, right, that's our b over 2. We get 2. And notice that that is squared, right? So that's our b over 2 squared term is, I guess I'll write it out just to be more clear. So our b term is 4 over 2 squared, right? And notice that 4 over 2 is the same thing as just 2, right? So we just get 2 squared that we have to add on both sides. Okay. Notice on the left side, since we have a perfect square now, we can factor that. So we get x plus 4 over 2, which is just x plus 2 squared. And then notice on the right side, we get 1 plus 2 squared. 2 squared is 4, so we just get 1 plus 4, which is 5. So we have x plus 2 is equal to 5. So we can square root both sides now. X plus 2 is equal to plus or minus square root of 5, right? And then the last thing we need to do is just subtract by 2 on both sides, right? So we get x is equal to, I'll put that first, negative 2 plus or minus the square root of 5. Right, I could put the negative 2 on the left or the right side. It doesn't really matter. I just like putting the roots to the right of it just to make it look nicer, in my opinion. Okay, so we found what x equals, right? So we have either negative 2 plus the square root of 5 or negative 2 minus the square root of 5. Right, so we could, if we wanted to find an approximation for that, right, what we could do is plug the square root of 5 into our calculator, right, then add negative 2 to that, or do negative 2 minus the square root of 5, or we could find decimal approximations. I want exact answers right now, though. And since I want exact answers, I'm going to leave it in this form. Okay, so I will just write this out just to be a little bit more clear. So x is equal to negative 2 plus the square root of 5, or x is equal to negative 2 minus the square root of 5. Right, either or. Okay. All right, so we will move on to the next page now. So this is going to be an example of when we might want to complete the square, right? So on the next one says, we have this formula for compound interest. So it says, suppose that an amount of money P, so we just put some amount of money invested at a rate R, right? So this is just our interest rate, and it's compounded annually. So after T years, so after some amount of years, the amount in our account, right, or our balance is given by this formula, right? So this is the amount after some amount of years. The P is just the original amount that we put into the bank account. And then the 1 plus R is just our interest rate, right? And then T is just how many years it's been in that bank, right? So the question says, use the compound interest formula above, right? So this formula right here, to find the interest rate R. So the first thing before I even read the question is I know that I'm solving for R here, right? Since I'm solving for R, that means I have to know what A is equal to, I have to know what P is equal to, and I have to know what T is equal to, right? I have to know those because I'm solving for R, okay? Okay, so it says in 2 years, notice that that's what T is, right? So T is equal to 2, we have 2 years. An investment of $80,000, so that's our original amount, that's P, right? Grows to an amount of $101,250. So notice that's what it grows to after the 2 years. So that's how much we have after it grows. So what we can do, or what we can say here, is that we know everything but R, so what we're trying to solve for is R, right? So let's plug in everything that we know into this equation. So we know that A is 101,250, 1,250. That's equal to 80,000 multiplied by 1 plus R, right? Because we don't know what R is. And we know T is equal to 2, so that's all just squared. Okay, good. So the question is now what can we do? Well, we can start solving for R. Maybe the first thing we do is divide by 80,000 on both sides, right? So we have 101,250 divided by 80,000 equal to 1 plus R squared. Okay. And notice that we have a squared term on the right. Oops, we have a squared term on the right, and on the left we have some number, right? So notice that this just takes the form of u squared is equal to d, right? We have an algebraic expression on the right, right? So maybe it's just flipped around, right? So we have the d on the left rather than the right, but still the same thing, right? So we have an algebraic expression squared on the right, and then notice that we have on the left just some number. So what we can do is we can just take the square root of both sides, right? So if we take the square root of both sides, and I'll switch the order and kind of start up here just to make sure I have enough room. We'll go up here. Notice that we have 1 plus R on the left now, since I'm switching the order, right? So we're taking the square root of both sides, is equal to, and I'll just let you know that these two huge numbers simplify to 81 over 64, right? So after we take out all our common factors, and we took the square root of that, right? So when we take the square root of both sides, we of course have to have plus or minus. And then notice that R isn't by itself, so we have to subtract 1 on both sides, right? So what I'm going to do is I'm going to say R is equal to, and before I subtract the 1, notice that I have a perfect square on the top and the bottom here. So I'm going to take the square root of the top, square root of the bottom. We get plus or minus 9 over 8. And then remember that I'm subtracting 1 on both sides. So what I'm saying here is R is equal to either 9 over 8 minus 1 or a negative 9 over 8 minus 1. So we either get R is equal to, if I subtract the positive versus the negative, we get 1 over 8. Or if I have the negative case, we have what, a negative 9 over 8 minus another 1 or minus another 8 over 8, right? So we get, or a negative 17 over 8. But remember the context of the question. So the context of the question asks, what is the interest rate? And notice that it's growing, right? It's starting at 80,000 and it's growing up to 101,000, right? So we know that it's growing. Since we know that it's growing, it can't have a negative interest rate, right? It can't have a negative interest rate. So that answer can't be it. So our interest rate has to be 1/8 because it's the only positive interest rate. Okay. All right, on the next one, this one says you invest $3,000 in an account whose interest rate is compounded annually. Then it says after 2 years, the balance in the account is $4,320. And then it says find the interest rate R. So notice here that we're doing the exact same thing as this problem, right? We just have different numbers. So it's the exact same thing as this problem, but with different numbers. So I know that A is going to be what it's worth after the time that it grows. I know that T is how many years it grows for, so 2 years. And then I know that my principal, or my P, is just how much that I put in at the start, right? So if I do that, we get A, which is 4,000, maybe we'll write it a little while, 4,320 is equal to our principal, so 3,000, multiplied by 1 plus R, right? And I know it's raised to the T power, in this case, T is 2 again. Okay, after I do that, notice that I can divide by 3,000 on both sides again. If I do 4,320 divided by 3,000, check my notes, it should equal 1.44. So we get 1.44 on the left. On the right, we get 1 plus R squared. So notice we'll take the square root of both sides again. So we get 1 plus R is equal to the square root of 1.44 is 1.2. So plus or minus 1.2. So maybe I'll make it a little bit more explicit. Take the square root of both sides. And then notice that I can subtract 1 on both sides, right? So we get R equals plus or minus 1.2 minus 1. And then notice that the only positive answer that I can get is the positive 1.2 minus 1, which is equal to 0.2. Right? Because the other answer, we get a negative interest rate. But we know that we can't have a negative interest rate again, right? Because we grew our account. Okay, so our interest rate is 0.2, right? Or we could say that it's 20%. Or 20%. Right, so 0.2 is the same thing as 20%. So our interest rate, 20%. Okay. So I'll keep moving on in just a second here. So the next thing that we're going to do here, we're going to talk about the Pythagorean theorem. So hopefully it's pretty familiar what the Pythagorean theorem is. The Pythagorean theorem just says that if we have a right angle, the square of the sides of A and B, the square of the sides is equal to the square of the hypotenuse. Okay. So the sum of the square of the length of the legs of a right triangle is equal to the square of the length of the hypotenuse, right? So stuff that we've seen before, not a problem. But now we're going to apply it here. So this one says, this example says, a supporting wire is to be attached to a 70-foot, to the top of a 70-foot antenna, right? So we have a 70-foot antenna, so 70-foot antenna. And then it says if the wire must be anchored to 70 feet from the base of the antenna, what is the length of the wire required, right? So we have this antenna that's 70 feet, and we're saying that this wire has to be anchored 70 feet from the base, right? So we can get this triangle here. And then it says, since the supporting wire, the antenna and the line on the ground between the base and the base of the supporting wire form a right triangle, right? We know that's right. It says draw a picture to help you solve for the length of the wire, right? So we don't know what this length is here. We don't know what the length of the wire is, but we could say it's C, or maybe I'll write W. We'll do W for wire, right? And that's what we're trying to find. So since I have this right triangle, now I can say, well, how can I solve this? Well, we know that A and B, right? We know what our A and B is. We know where A and B is. But we don't know what C is, right, in this case. So I can say that A and B are both 70, right? So I can say, well, the equation for this is 70 squared plus 70 squared is equal to, and instead of C, we'll use W, right? So it's W squared. Well, notice that 70 squared here, that is what, 4,000. If I add those together, it would be, let me check here, so 70 times 70. So we get 4,900 plus another 4,900 is equal to W squared. So we get that W squared. If I add those together, notice that that's 9,800, right? And then we'll square root both sides. Right, so when we add those together, we square root both sides, so we just get the length of the wire W on this side. Now notice that normally we have to put a plus or minus sign, right? But the length of the wire can only be positive, right? We can't have a negative length of wire. So I'm only going to take the principal root, or the positive case in this case, right? So we get W is equal to the square root of 9,800. So we can say that the length of the wire W is approximately equal to, and I'm just going to take the square root of that in my calculator, is approximately equal to 98.995, right? And remember that we have it in feet, so I forgot to mark that, but it's all in feet, right? So notice that this has to be answered in feet. Okay. So the length of this wire, and that makes sense, right? So the length of the wire is more than one of the legs, right? So it's longer than 70 feet, right? And we know that the diagonal of any triangle, right, the hypotenuse of any triangle is going to be longer than either one of the legs. Otherwise, it wouldn't be the hypotenuse. Okay. All right, so we've gotten that one done. Let's move on to 8.2. So 8.2, we're going to go back to the quadratic formula again, right? So when we want to find the solutions of the quadratic formula, what we've seen before, right? Whenever we have something, a trinomial, right, in this form, where you have an x squared term, an x term, and a constant, and that's equal to 0, with a is not equal to 0, right? A can't be equal to 0, because if it was, it would just cancel out this first term, right? So it has to be a non-zero term. It's given by the quadratic formula, right? And I'm not going to prove that here, but if you want to, you can look up on YouTube, see a proof of that, and they'll kind of work on doing this. Or even if you wanted to discover it yourself, I'll kind of get you started. What I would do is I would subtract c on both sides, right? So we kind of get this ax squared plus bx equals a negative c, right? And then after you do that, I would complete the square like we did in 8.1 just a little bit ago. If you complete the square, you'll eventually kind of get out to this right here, where we get this negative b plus or minus the square root of b squared over or minus 4ac, right? So if you want to try that out yourself, feel free. I'm going to omit that proof here, though. Okay, so this first one says we're going to solve this. And I forgot to put, but this is equal to 0. So we're going to solve that. And the way we're going to do that is just plugging it into this formula, right? So we don't have to do any guessing. We don't have to complete the square, nothing like that. We can just solve by using a quadratic formula. So notice that my a term here, a is equal to 1, right? That's just our coefficient in front of the x term. Our b coefficient in this case is 8. And our c coefficient in this case is 15. Right? So we're just going to plug those into our quadratic formula. So we get x is equal to x. Okay, there we go. So we get x is equal to, maybe, x is equal to negative b, right? So negative 8 plus or minus the square root of b squared, so 8 squared, minus 4 times a, which is 1 in this case, multiplied by c, which is 15 in this case, right? Right, and then that's all over 2a, so 2 times 1. Okay, so we can do a lot of simplification with that. So the first thing I can do is everything in the square root, right? So if I do everything in the square root, notice that this is 64 minus 60, right? So we get the square root of 4 in there. So this simplifies too. And maybe I should have moved everything over a little bit. So I'll continue this up at the top. Sorry about that. So we get x is equal to negative 8 plus or minus the square root of 4 over 2 times 1, which is 2. Right, so we just simplify everything in the square root and kind of end up with this answer, right? So we can simplify this more. We know that the square root of 4 is 2. So we get negative 8 plus or minus 2 over 2. And then notice that we have negative 8 plus 2 and negative 8 minus 2. Negative 8 plus 2 is negative 6 over 2, right? Or negative 8 minus 2 is negative 10 over 2. Negative 6 divided by 2 is a negative 3. Negative 10 divided by 2 is a negative 5. Right? So we get x is equal to negative 3 or negative 5. Okay, right? So all we're doing here is just plugging into the formula. After we plug in the formula, it pops out 2 answers, right? Easy enough. So let's do that same thing on this one. And I'm going to zoom in just a little bit so I have some more room here. Notice that we have to do a little bit of work on this one first. So the work that we have to do is we have to get everything to the left side, right? And the reason we have to do that is because for our quadratic formula to work, we have to have everything on the left is equal to 0, right? So we have to do a little bit of work to get everything on the left side so it's equal to 0. So here I get 2x squared plus 4x minus 5, right? So we're just doing the inverse of the right side to get it over to the left is equal to 0. Okay. Notice that a here, notice that a is equal to 2, b is equal to 4, and then finally c is equal to negative 5. C is equal to negative 5. So if I plug that into my formula, x is equal to negative b, right? So negative 4, negative 4. Plus or minus the square root of b squared, right, which is 4 squared, minus 4 times a times c. So that's 2 and negative 5, right, all over 2a, which is 2 times 2. Okay. Notice that we get negative 4 over here. We get 4 on the bottom. And then when we simplify this, we get 16. 16 plus, what? Let me write that down just to make sure I'm doing it right. So x equals negative 4 plus or minus the square root of 16. We get 2 negatives, right? So that turns into a positive. We get 4 times 2 times 5. We get 40, right? So we get plus 40 over 4, right? So we can keep changing this, right? So we can say that 16 plus 40 is 54, right? So this is equal to negative 4 plus or minus the square root of 56 over 4, right? And we can keep simplifying this, right? So maybe I'll do one more step. Notice that when we're dividing this by 4, we can divide both terms by 4, right? So I can divide the -4 by 4, and I can divide the square root of 56 by 4. So I'm going to do that. So I'm going to actually go up here. So -4 divided by 4 is a -1, plus or minus, right? Still the square root of 54, or sorry, 56 rather. 56 over 4. Right, and that's what our x is equal to. Now again, if I wanted to find a good approximation to this, I could do the square root of 56 in my calculator, divide that by 4, and then find the two roots. Right? But I'm not going to do that, so I'm going to leave it as that. So my final answer is x is equal to -1 plus or minus the square root of 56 over 4. Okay. So one thing that we're going to talk about after this now is we're going to talk about the discriminant of the quadratic formula, or just of a quadratic equation, right? And all the discriminant is the term under the square root, right? So it's this term under the square root, or these two terms, right? B squared minus 4ac. So the reason that it's important is it tells us what type of solutions that we have, okay? So it tells us what type of solutions that we have. So when we have the discriminant, so when we have this thing is equal to, or rather is greater than 0, right? So it's a positive number. And we know that if it's a perfect square, right? So perfect square is like 1, 4, 9, 16, so on, right? So all of our perfect squares. Then we have two unequal real solutions. So what that means is if I have a graph here, right? When I have this quadratic equation, we have something called a parabola, right? We have this parabola that goes kind of like this and goes like that, right? So we have these two places where it crosses the x-axis, right? Which are our solutions, right? The two x-intercepts. So when it's greater than 0 and it's a perfect square, we have those two solutions, okay? When it's not a perfect square, we still have the same graph, but instead, they're going to be irrational conjugates, right? And what that means is we have x minus a and x plus a, right? Where a is just some number, right? So we have these irrational conjugates, right? And that's kind of what we've seen before, right? When we had some number, let's just say a, that's actually a bad example. Maybe we should say some t, right? Some number t plus or minus the square root of maybe s, right? And then we had, maybe we already divided by 2 or something on the bottom, right? So we have some number plus or minus the square root of this, right? And that's where our conjugates come from, right? So we have plus the square root of s term and minus the square root of s term, right? So that's where our conjugates come from. Now, if we have this discriminant is equal to 0, right? So when this evaluates to 0, we only have one solution. So what that looks like is maybe we have something like this, right? And it comes down and just touches the graph and goes back up, right? So that's where we have only one solution, okay? And then finally, if it's a negative number, right? So it's less than 0, we have two imaginary solutions. So maybe the graph is going to look something like this, right? So we have this, and maybe it comes down, but it never actually touches the x-axis, and it kind of goes up. So we have no real solutions. It never touches the x-axis. So that just means that we have two imaginary solutions, okay? Okay, so if we want to find the discriminants of this equation, right? So this quadratic equation, we have to know what b is equal to, a is equal to, and c is equal to, right? So we know here a is equal to 2, b is equal to -4, and then c is equal to 3. Right, so our discriminant d is equal to b squared, so -4 squared, minus 4 times a, which is 2, times c, which is 3, right? So we get 16 minus 4 times 3 times 2, which is what, 24, so minus 24. And notice that that is a negative 8. So I found my discriminant, right? My discriminant is equal to negative 8. And that means since it's less than 0, right? That's our very last case. Since it's less than 0, we have two imaginary solutions. Right? And this will be important in our next section where we're actually going to start graphing these, right? So we're not just looking to see what our discriminants are and stuff, but we're going to use all these tools to find out what the graph of one of these is going to look like. Okay. All right, on the next one, we have to do a little bit of work first, right? So we need it in the form of ax squared plus bx plus c is equal to 0, right? So we have to make this equal to 0 before we can find the discriminant. So what I'm going to do here is I'm going to subtract 20x on both sides and add 25 on both sides. So if I do that, we get 4x squared minus 20x plus 25 is equal to 0. Right? And then after I do that, now I can find my discriminant, right? So we know that a is equal to 4, b is equal to negative 20, b is equal to negative 20, and c is equal to 25, right? Those are just our coefficients in front of the variables, and then our constant. So our discriminant is, I'll just write it down again, b squared minus 4ac. Substitute in our values here. We get negative 20 squared minus 4 times 4 times 25. Notice that negative 20 squared is 400. Minus 4 times 25 is 100, right? Times another 4 is 400, right? So we get minus 400 here. And notice that 400 minus 400 is 0, which is our discriminant. And then let's look back at our cases really quick. When our discriminant is equal to 0, that means there's only one solution, right? There's only one real solution. So only one real solution. Okay. Okay. Right, and we could make up more cases if we wanted, but I think that's good for now, right? So we could end up with, you know, these conjugates, these real solutions. Okay. So now I want to take you back to something we did a few weeks ago. So something that we did a few weeks ago, we had this zero product principle, right? And I misspelled that, right? It should be LE. So we have the zero product principle, where if we have two things multiplied together, and we know that one of them is equal to 0, then we know that the product is equal to 0, right? So we know that the product is equal to 0, right? So remember we had something like, as an example, we had like maybe x minus 3, and then x plus 2 is equal to 0, right? So we can find our solutions for x because we know one or the other has to equal 0. So what we're going to do this time is we're going to go in reverse with this. So I'm going to give you solutions to x, and after I give you those solutions, I want to know what a quadratic equation looks like that has those two solutions. Okay? So I'm going to say, this is my solution set, right? So x is equal to negative 5/6, or x is equal to 1/3, right? So what I want to do is I want to write these as, and I'll kind of continue this example, right? So we had two cases, right? We either had x minus 3 is equal to 0, or x plus 2 is equal to 0, right? I want to write these equations to look something like this, right? So we have x plus or minus something is equal to 0, and then x plus or minus something is equal to 0. So what I can do on the first one here is I can say, well, this is just x, oops, so this is just x plus 5/6 is equal to 0. And then this is x minus 1/3 is equal to 0. Right? So now that I have these two different equations that are both satisfied for x, right? I can say, well, hey, this is my A is equal to 0, and this is my B is equal to 0. So what I can do is have AB is equal to 0, right? Since AB is equal to 0, right, from our 0 product principle, I can say, I'll erase that, I can have x plus 5 over 6 multiplied by x minus 1 over 3 is equal to 0, right? Because I know one of those has to be equal to 0. We don't know which one, but we know one of them has to be equal to 0. Or maybe even both of them equal to 0, right? We don't know. But then I asked to write a quadratic equation with the given set, right? So this isn't quite a quadratic equation yet, right? But the way we can find a quadratic equation is just by foiling it, right? So if I foil this, we get x squared minus 1/3 x plus 5 over 6x minus, multiply these two, we get what? 5 over 18 is equal to 0. Okay, so we get 5 over 18 is equal to 0, right? Okay, so after we do that, what can we do? Well, we can combine our like terms, right? So we'll just combine our like terms, and then we have our answer, right? So we have x squared. This is the same thing as negative 2 over 6, right? So negative 2 over 6 plus 5 over 6x. We get what? 3 over 6, or 1/2. So we get plus 1/2 x minus 5 over 18 is equal to 0, right? So we get that is our quadratic equation, right? So that's the equation that satisfies, that's our equation that satisfies these two solution sets, right? So these two solutions, right? So if we were to work it backwards, we would get, the same answers, right? So that's how we do this. So we have two solutions. So I'll do it one more time. We have two solutions, right? So what I'm going to do is I'm going to write these as two different equations. So we get x is equal to negative 3 over 5, or x is equal to 1 over 4. I want to get 0 on one side. So I will add 3/5 on both sides here. So we get x plus 3 over 5 is equal to 0. Or x minus 1 over 4, right? 1 over 4 is equal to 0. And then we'll use that 0 product rule that we had. We use that again. So we get x plus 3 over 5 multiplied by x minus 1 over 4 is equal to 0. And then we'll do the same thing, right? We're going to FOIL it. So we get x squared plus, sorry, that should be a minus, right? Minus 1 over 4x plus 3 over 5x. And then we get minus 3 over 20 is equal to 0. There should be an x there, right? And then we just have to combine our like terms again. So when we combine our like terms, you should get a positive 7 over 20. So when we combine those two, we do that, we get x squared plus 7 over 20x, and then minus 3 over 20 is equal to 0. Okay. And if you wanted to simplify this a little bit, maybe you like to work with nice numbers, you could multiply both sides by 20, right? Because then the denominators would cancel. But again, it's not necessary. This is our final answer, right? So just remember what we're answering. We're answering a quadratic. We're finding a quadratic equation where the two roots of this equation are negative 3/5 and a positive 1/4. So an easy way to check that, remember, is just to use the quadratic equation. Would be the easiest way. Okay, so the next thing that we're going to do is we're going to look at another Pythagorean theorem problem, right? So we're going to have to deal with right triangles again. So this one says the hypotenuse of a right triangle is 6 feet long. Right? So that's right here, 6 feet long, right? One leg is 2 feet shorter than the other, right? So we have one leg with length x, right? We don't know what it is, but we know that the other one, the relation to the other one, we know that it's 2 feet shorter, right? So we have to subtract 2 off of it. Okay. So it says find the lengths of the legs, right? So we have to find the length of this one and the length of this one. Okay. So to find that, maybe a hint that I've kind of already given away is to use the Pythagorean theorem, right? So I know that the length of this squared plus the length of x squared is equal to 6 squared, right? So we get x minus 2 squared plus x squared equals 6 squared, right? So all we're doing here is just using the Pythagorean theorem. And notice that we can solve for x here, right? And the reason we can solve for x here is because we only have one variable, right? So if we didn't know the lengths of either of the legs, right, and we didn't have any relation between them, we wouldn't be able to find this. But since we have a relation between them that share a variable, we can find the length, or we can find what x is equal to, right? So what I'm going to do first is I'm going to FOIL x minus 2 squared, right? So we get what, x squared, let's see, minus 4x plus 4, right? So that's what this evaluates to right after I FOIL it. And then x squared is just x squared, right? And 6 squared is 36. Now notice I think the easiest thing to do to find out what x is equal to is to just use the quadratic equation, right? So before I can use the quadratic equation though, I need to make sure that one of the sides of the equal sign is equal to 0. So what I'm going to do here now is I'm going to combine my like terms, and then I'm also going to subtract 36 on both sides. So we get 2x squared minus 4x, and then we have this 4 right here. This is our constant term, right? And we're subtracting 36 on both sides. So 4 minus 36 is a negative 32. A negative 32. And that's still equal to 0 now, right? Since I subtracted 36 on both sides. Now notice I can make my life easier before I use the quadratic equation though, right? I can divide everything by 2 since they all share a common factor of 2. If I do that, we get x squared minus 2x minus 16 is equal to 0. Yeah. And then after I do that, notice that my a term, right, my a is 1, b is negative 2, oops, b is negative 2. And then finally, c is equal to negative 16. All right, so what I'm going to do here is plug this into the quadratic formula. So we get negative x is equal to negative b, right? So 2 plus or minus the square root of b squared. So that's 4, right? Negative 2 squared minus 4ac. 4a is 1, c is negative 16 over 2a, 2 times 1. Right? So notice that we'll just get 2 on the bottom, right? 2 times 1 is just 2. Okay. So after I do that, right now I can start simplifying everything. So notice that this is just, let's simplify this, x is equal to 2. If I evaluate everything in the square root, we get 4, we have 2 negatives, so we're going to add now, right? So I get 2 negatives, so we get the square root of 4 plus 4 times 16, which should be what, 64? Yeah. And that's all over just 2 still. Okay. And then after that, I get x is equal to 2 plus or minus the square root of 68 over 2. And notice that we're trying to find the length of one of the legs, right? So we need a positive value. Notice that if we subtract the square root of 68 on the top, we're going to end up with a negative value. So here, I just need to take the positive of the two, right? I need to have one of the answers that's positive. So in this case, we just take 2 plus the square root of 68 over 2, right, as our answer. And I will just kind of approximate that in my calculator really quick. So take the square root of 68 plus 2 divided by 2. We get x is about equal to, so approximately equal to 5.12, right? So that's what our x is equal to. But remember that our question, maybe I'll zoom out a little bit, says find the lengths of the legs. So the first thing is easy, right? My first x is just equal to 5.12, right, approximately. But then the length of the other leg is equal to x minus 2, right? So we have 5.12 minus 2, right? So that's just equal to 3.12. So that's the length of my legs, is 3.12 and 5.12. Okay. All right, so we'll do another example here. So this one says the function below models a woman's normal systolic blood pressure at age A. So it says use this function to find the age to the nearest year of a woman whose normal systolic blood pressure is 115 millimeters for Hg. I know that's an element. I forget what it is. I think it's mercury. Right. So we have this formula here, right? We're given this function, and we need to find out what A is equal to, because we don't know what that is yet. But we do know what P of A is, right? So P of A is just the 115 mmHg, right? That's what her normal blood pressure is. So I know that P of A is equal to 115, and I know that's equal to everything on the right side. So 0.01A squared plus 0.05A plus 107. Right. So the first thing I can do here is, before I use the quadratic formula, I need to subtract 115 on both sides, right? And the reason I need to do that is because I need 0 on one of the sides to be able to use the quadratic formula, right? So I have 0 is equal to 0.01A squared plus 0.05A minus 8, right? Okay, so after I do that, notice that my A term is equal to 0.01, B is equal to 0.05, and C is equal to negative 8, right? Negative 8. So the next thing that I can do is plug that into the quadratic formula. So notice my variable here is A, right, rather than X. So A rather than X. So A is equal to negative B, right? So negative 0.05 plus or minus the square root of B squared, 0.05 squared, minus 4 times A, which is 0.01, multiplied by B, multiplied by C rather, right, which is negative 8, all over 2 times A, right? So 2 times 0.01. Okay. So obviously, after writing out that, we're kind of running out of room, right? So what I'm going to do is I'm going to simplify this down a little bit, and maybe I'm going to go up here to the top again. So when I simplify this all out, we get A is equal to negative 0.05 plus or minus the square root of, let's see, 0.3225, right? So after you work everything out under the square root, that's what it equals to, over 0.02, right? 2 times 0.01 is 0.02. So when I evaluate this on my calculator, we get A is approximately equal to, and notice that we'll get 2 different answers, right? Because we have a plus and a minus. We get A is approximately equal to 26, or A is approximately equal to a negative 31. Okay. So then the question is, which one's the right answer here? Which one's the right answer? Well, notice that we're asking for a woman's age, right? We're asking for a woman's age. So notice that we have a negative answer, and right, we can't have a negative age for somebody. So the only answer that makes sense here is 26. So that's going to be our answer for this question, right? Because it has to be a positive age. And then the negative 31 is just an extraneous answer, right? Okay. So that's how we find the age of a woman with a normal systolic blood pressure of 115, right? So we just kind of solve it, use the quadratic formula. Okay. Any questions so far? Okay, so I don't see any questions yet. So we'll move on to 8.3. Oh, okay. So yeah, we'll move on to 8.3 then. So this will be the last section. Hopefully I can get through it tonight. If not, we can always cover it on Thursday. So 8.3, we're going to start talking about the graphs of quadratic formulas, or quadratic functions rather. So what we call the graph of any quadratic function is a parabola. So parabolas are either shaped like bowls or inverted bowls, right? So we either have something like this, right? Or we have something flipped the other way. They kind of look like that. So we're going to look at this equation for just a general quadratic formula, right? So we have y is equal to that, right? Or just f of x, it doesn't really matter. So if a is positive, if our term here is positive, so maybe I'll write this over here, is a is greater than 0, it's going to open upward like that. And if a is negative, so if as a is less than 0, we get a downward bowl, right, or an inverted bowl. So it just depends on that leading term a, okay? So then we have another special point, or we have a special point called the vertex, or the turning point of a parabola, which is just the lowest point on the graph if it opens upward, right? So if we have this graph again, it's just this lowest point here. It's our vertex. Or if it's opening downward, it's the top point, right? When it's opening downward, okay? So that's also a vertex. So notice that we have a minimum point, right, or our lowest point when it's a positive quadratic, and we have this highest point when we have a negative quadratic, okay? So the first thing that we'll talk about is a special form of a quadratic equation, right? So they've kind of factored this original equation into this x minus h here, right? So they've factored it. And after they factor this, we get a really nice result. And this really nice result is that if we were to graph this equation, we have this point, this vertex that we've been looking at the point h comma k, right? So let's just draw a graph here. Draw a graph. And let's say that maybe this point right here is k, and maybe this point over here is h, okay? And then let's also assume that a is positive, right? So we'll assume that a is positive, okay? So what I can say is that at this point right here, at k comma or h comma k, right? That is either a minimum or a maximum point, right? That's either our lowest point or our highest point. Since I assume that a is greater than 0, we know that it's our lowest point. So we're going to have some equation or some graph, right, that kind of looks like this, right? Our parabola is going to go up like that. So that's going to be our minimum point, is that h comma k point, right? And then alternatively, we'll just do a is greater than 0 here. If we have a is less than 0, I'm going to use the same point again. it's going to look something like this, right? It's going to look something like that. So this is if a is less than 0, right? So we have it pointing downwards. Okay, so those are two important things that we have on this graph, is when we have this special form here. And we'll talk about general forms after this. Okay, so I'm going to kind of guide you through the steps here. So we're going to have 5 different steps. When we have a function, right? So we have f of x is equal to this form right here, right? And this is exactly what we have up here, right? We have an a term, we have an x minus h term in here, right? So instead we're just adding 4 rather than the subtraction. And then we have this plus k term out here, right? So it's in exactly the form that we want. So now that we know that it's in exactly the form that we want, we have to do number 1, right? We have to determine, is it opening upward or downward? Notice that our a term is less than 0, right? So it's a negative term. So we know that it's going to open downwards. We know that's going to open downwards. Okay, so that's step 1. Step 2 says determine the vertex here, right? So our vertex is h comma k. I'll start with k first. So we know k is -8, right? That's the start, so -8. But notice that inside here, we have x plus 4, right? And we need to have it in the form of x minus h. We need to have it in the form of x minus h, right? So this is just the same thing as saying we have x minus a -4, right? So it's in this form of x minus some number h. So notice that I have it in this form now. So my h is equal to a -4, right? Because we have to have it in that form. Okay, now that I've done that, we need to find where our x-intercepts are. So to find our x-intercepts, we replace f of x with 0. So for our step 3, we're saying f of x is equal to 0. So I'll zoom out just for a little bit. So that means that this equation that we started with, we have 0 for f of x is equal to -2 x plus 4 minus 8, right? And then notice what I can do is divide everything by -2, right? So if I divide both sides by -2, we get 0 is equal to x plus 4 plus 4. Right? So I have to divide everything by -2. Then notice, oh, sorry, that's squared, right? Yeah, squared. Notice that I can subtract 4 on both sides. -4 is equal to x plus 4 squared. I can square root both sides. So we get the positive or negative square root of -4 is equal to x plus 4. Subtract 4 on both sides, we get x is equal to -4 plus or minus the square root of -4. As a little side tangent here, we can say that this is the square root of -1 times the square root of 4. Right? Notice that that means that we have -1 is just I, right? I multiplied by the square root of 4, which is 2. That's 2 times I, or I times 2. Right? So my intercepts are at -4 plus or minus 2I. Right? So we know that we're never going to touch the x-axis because we have these imaginary roots, right? Okay, so we found our roots, right? We're not going to touch the x-axis. And then the number 4, so maybe I'll go down here now. Number 4 says to find our y-intercept by replacing x with 0. So I'm going to rewrite our equation here. Oops, rewrite our equation. So we have, sorry about that. So we have -2, x is going to be 0, right, to find our y-intercept, plus 4 squared minus 8, right, and that's equal to f of x. Okay, there we go. So I've rewritten that just substituting in 0 for x. So notice that we have -2, -2, multiplied by 4 squared minus 8 is equal to f of x. And after you work that all out, you get to f of x is equal to -40. Right? So f of x is equal to -40. So now that I know that, I know my y-intercepts, I know my x-intercepts, I know what the shape of the graph is going to look like, and I know my vertex, right? So we can graph this now. We have everything we need to graph this. So the first thing I'm going to note is my vertex. So that's number 2, right? My vertex is h comma k, right? So that's -4, -8. Right? So if I plot that on my graph here, maybe we have a -4 here, -8, maybe a little bit further down, -8. Right? That's where my vertex is. I know that it opens downwards, right? That's number 1. I know it opens downwards because we have a negative in front. So since it opens downward, I know it's going to go, like this way, right? It's going to go this way and this way near the end. So I'm just going to keep that in mind. But I also know that my y-intercept, this f of x is equal to -40, right? That's just the same thing as saying 0, comma, -40, right? 0, comma, -40. So I can say that down here at -40, right? It's probably a lot farther than that. But I can say that it crosses the axis at -40, right? And then it's kind of bad, so maybe I'll something like that, right? And I know that this is the vertex. Since that's the vertex, I can say that this is just reflected on this side, right? So they look like the exact same thing on both sides. So I should have a parabola that kind of looks like this, right? And hopefully it draws a little bit better for you guys. But I think what I'll do just to kind of bring this point home really quick is I'll actually go into Desmos really quick. Maybe I can show you this, Desmos. And we'll see the graph that we just had. Okay? So we're going to see that graph maybe a little bit better. Okay. So our equation here is equals -2 plus 4. Hang on just a second. Let me see if I can get this up here. Okay, there we go. So I'll stop sharing just for a second, and I'll share my screen with as Desmos now. So notice that this is exactly what the graph's going to look like. Right? So notice that we have a point at -40 here, right? 0, -40, which is what we found. Our vertex should have been -4, -8. Yep, it is. And notice how it's kind of reflected along that vertex, right? That if we draw a horizontal, or rather a vertical line right through the vertex, it's kind of flipped on both sides, right? There's a little bit of a better drawing. And notice that it doesn't have any intercepts on the x-axis, right? Because we knew that it was going to be imaginary for our intercepts, right? So notice that there's no intercepts on our x-axis. Okay, so we'll go back to our notes now. If I go back to our notes. Okay, so we'll go back to our notes here and we'll go on to the next page. So the next page, we're going to do a more general form, right? So whenever we have a quadratic equation in the formula or in the function, right, we have a times x squared plus bx plus c, right? So that's what we've been dealing with a lot before. We're going to do the same steps, but we have to do it a little bit differently. So the first step is if it opens upwards or downwards. Notice that we have 1 for A here, so its A is greater than 0. So it's going to open upwards. For B, or for the second one, when we want to find our vertex, our 2 points is for our x value, it's going to be negative b over 2a. And notice that that negative b over 2a here, that's just the rest of the equation from our quadratic formula, right? Minus the discriminant, right? So that's where we find that vertex at. So negative b over 2a is, in this case, b is, maybe I'll write this down a little bit more here. So we get a is equal to 1, b is equal to negative 4, and c is equal to 6, right? Because that's going to come in handy later. Okay, so after we have those 3, we have negative b over 2a for our first point, right? And that's also going to be important for our function at that number. So I'm going to have negative b, which is negative 4, over 2a, 2 times 1, is equal to, we get 2 negatives, which is equal to a positive, right? 4 divided by 2 is 2. Okay, so we know that our x coordinate here is going to be 2. And our y coordinate is the function at 2, right? That's our function at 2. So all I need to do here is plug in 2 into our function up here, right? So our function at 2 is equal to 2 squared minus 4 times 2 plus 6, right? Simplifying that down, we get what? 4 plus 6, which is 10, minus 8, which is 2. Right? So just combine our positives and subtract the 8 in the middle. So notice that means our vertex is at 2, 2. Okay, so we found our vertex and we know that it opens upward, right? So we can do number 3, right? So number 3 says find out the x-intercepts. So notice that the x-intercepts is when this is equal to 0. So notice that 0 is equal to x squared minus 4x plus 6. Okay. So we can quickly solve for that, right? We can just use the quadratic formula. So if we use the quadratic formula, remember our a, b, and c from up here, we get x is equal to negative of a negative 4, right? So negative b plus or minus the square root of b squared, negative 4 squared, minus 4ac, running out a little bit of a room here, 6, right? So 4ac all over 2a, 2 times 1. And I won't work through this one, but I'll just give you the answer. So our answer should be x is equal to 4 plus or minus the square root of a negative 8 over 2. And notice that we're going to have imaginary roots again, right? So we're going to have imaginary roots because we have that negative 8, right? The square root of negative 8. Okay. So I don't need to necessarily know what those are because I'm never going to cross the x-axis, right? So I'm just going to leave it like that. And then for 4, we want to find the function at 0, right? Because we want to know what our y-intercept is. We want to know what our y-intercept is. So our function at 0, we just substitute 0 wherever we see an x. So 0 squared minus 4 times 0 plus 6. Notice that all of our terms with 0 and them cancel, and we get 6. So we know that this parabola crosses the y-axis at 0, 6. And then now we're ready to graph it, right? We've done all 4 of the steps. So if I draw this graph, I know that it's going to cross the y-axis at 6, right? We'll say at 0, 6. It's never going to touch the x-axis, right? Because they have imaginary roots. And what else do we know? We know the vertex is at 2, 2, maybe there and there, right? And then we know that our last part from 1, we know that it opens upwards, right? We know that it opens upwards. So we can connect it with a smooth line. Maybe it's going to look something like that, right? It should be kind of mirrored on both sides, so it looks like the exact same thing. Okay, so we know that we can graph these quadratic functions, right? We can graph them in this form, in this general form, which we can always do as long as it's a quadratic equation, right? We can always change it so it looks like that. Or we might have some special forms like this that we can use, right? Either one. So we can graph quadratic functions now just by kind of finding out some things about it, where the x and y intercepts are, where the vertex is, how it opens, right? Okay, so what we can do now is we can kind of specify a little bit more about these. So we can determine the domain and range of the original function, right? So we can use the second parabola from the preceding page. So I'm going to skip that. I made my own one up. So we're going to have another one here. So if we want to find the domain, we have to look at where all the inputs on the x-axis correspond to points on the graph. So this is just all of our possible inputs, our x values. And the range is just all of our possible outputs, or our y values. Okay. So if I ask you to graph x squared plus 1, notice that it's going to open upward, right? So a is greater than 0. It opens upward. If I look at my, if I do the quadratic formula to find my roots, I can tell you that there's going to be imaginary roots, right? Because we're going to have 0 plus or minus the square root of 0 squared minus 4ac, right? A is 1 and c is 1 over 2 times 1, right? So that's just our quadratic formula. Notice that we're going to have a negative square root, right? So we're going to have these imaginary roots. So we know it's never going to touch the x-axis. If I substitute 0 in for x, so we get f of 0 is equal to just 1, right? Or maybe I'll write it a little bit more explicitly. We have x, we substitute 0 in for x squared plus 1. That's just equal to 1. So we know it's going to cross the y-axis at 1, right? And then the last thing we need to do is find out the vertex, right? So remember, it's negative b over 2a. In this case, we know that b, we don't have just an x term, right? We have a 0x there if I wanted to kind of like insert that in. So I know that b is equal to 0 over 2 times 1, right, which is just equal to 0. So I know that I have a vertex at 0, but I already know where this crosses at 0, right? It crosses 0 at 1. So my point here is 0, 1. So that's where my vertex is. So if I wanted to graph this, I have a point at 0, 1, right? And I know that it opens upwards. Right? So it's going to look something like that. So the question is, what's the domain and range? So if I wanted to find the domain of this, what I can do is look at all the possible x values that I can choose. So the question is, where can I choose an x value, or where can I not choose an x value, right? Maybe that'll help. Well, the thing is, these arrows go out to infinity, right? So if I pick an x value here, or maybe it's a negative x value, I'm going to get some value up here, right, on this parabola. So what I'm saying is that no matter what value I pick all the way out to left, all the way out, maybe even to the left of the screen over here, right? No matter what I pick, I'm always going to get a value for y. And we can do the same thing in the positive direction, right? I can pick any one of these points, and we'll get a point on the line when we plug it into the function. So what I can say is that my domain, so all my possible inputs is equal to in interval notation, we go out from negative infinity all the way up to a positive infinity, right? All the way up to a positive infinity. So those are all my possible solutions. Okay, and then the question is, for all my possible inputs, what are all my possible outputs? So what are all my y values? So my range. So my range, notice that I can't have any negative numbers, right? So on my range, my y values, there's no negative number that I could pick down there, right? My very first value that I can pick is at 1 up here, right? My very first y value is 1. So I can say, well, my range goes from 1 all the way up to, and it looks like it goes up to infinity, right? So it goes all the way up to infinity. So my domain is just all my possible inputs. My range is just all my possible outputs. Okay. Okay. So one more special thing that we can do here, and maybe it'll make it a little bit easier to kind of look at what my range can be, is that I can look at minimum and maximum values. Okay. So whenever I have a quadratic, my domain should always be negative infinity all the way up to infinity, right? But my range is limited to wherever my vertex is, right? So that's that special 1 point. It's limited to where my vertex is all the way up to infinity if a is greater than 0, right? So I have a positive. And otherwise it's flipped, so from negative infinity all the way to up to 1 if a is less than 0, right? Or it's negative. So what I can say is that in each case, the value of x, or the value of the vertex, right, x, gives the location of the minimum or maximum value, right? So the value of y, so the function at that vertex, gives either the minimum or the maximum value. Okay, so I can use that information to find the minimum or maximum value and use that to determine the domain and range of this function, right? So I need to find, when this is equal to 0, right? I need to find what my minimum or my maximum value is, right? And the way I can do that is just find out where my vertex is, right? So if I want to find out where my vertex is, I need to find out what my x is, right? My x, my x, or I should just say vertex, right? So my vertex is equal to negative b over 2a, right? That's my x value for my vertex. Notice that my negative b over 2a, negative b is a negative 16, right? Which is positive after we have the negative, right? So negative of a negative 16 over 2a, so 2 times 4. Maybe I'll erase that 0 for now, right? So we have the negative of a negative 16, which is equal to 16 divided by 8, which is equal to 2. So my vertex of my x value, right? So maybe I'll write it like that, is 2. So I need to find where the function is equal to 2. So the function is equal to 2, right? And that'll give me my y value. So I have 4 multiplied by 2 squared minus 16 times 2 plus 1,000, right? So if I simplify that down, you should get 984, right? So we just combine all of our constants. So that's saying that our vertex, and maybe I'll write it up here because I'm kind of running out of room. Our vertex is equal to 2,984, right? So the question is this a minimum or a maximum? So notice that my a term, my 4, is greater than 0, right? So that means my parabola is going to kind of go up like that, right? So I know that this has to be a minimum. So I can put any value of x that I want in there. So my domain is equal to negative infinity infinity, right? And then my range is equal to, notice that I have a minimum, right? My lowest y value is equal to 984. And then my maximum value, notice it goes all the way up to infinity, right? So my maximum value here is infinity. Okay. And I think that I will save the last 2 pages for Thursday. And then I'll put a bunch more review questions on there as well, because I know this was a lot to digest tonight. So we will finish this on Thursday. If you have any questions or anything, feel free to stay around. If not, you're fine to leave, and I'll upload this to YouTube later tonight, so you can rewatch it if you missed anything. So we'll finish the last 2 pages on Thursday. Okay. All right. So the last 10 minutes are just for questions if you have any. Yep, if you don't have any questions, you're good to go. I'll post this annotated version online on the last announcement for anybody that missed it.